I'll be talking about the game of light. Everybody knows Game of Life, invented by John Conway, popularized by Martin Gardner, and pretty much quite a few generations managed to preserve their sanity during boring classes in high school by scrabbling, underneath the desk, right? But this is a metaphor, you can understand it as a metaphor for biological system. What about physicists? So I thought about some like a metaphor for mathematical physics, which would be corresponding to Game of Life, Game of Light. So what's the idea? Reality, physicists try to model it with mathematics. And so what about something like a pre-physics? It corresponds to the idea of, the idea would be to use very primitive notions, no arbitrary choices. Can we make something which would be simultaneously a metaphor for reality and maybe metaphor for theoretical physics and all models we produce? Corresponds to the idea of Wheeler, who always thought about producing pre-geometry, law without law, before you really measure anything. Is there anything like this? So let's try. Let's create a universe. First, you need things, they think, therefore they are, something like that, or places. Then you need, of course, a structure, connections. You're getting a graph, right? Next thing would be like some mathematics. Let's pick up the simplest possible mathematics you can do with one neuron. 1 + 1 is 0, right? Z2. And physics. So we can have states of vertex, can be on or off, like in a Game of Life. But same thing, you can have a state of edge. And so state of a graph would be certain subset of vertices being excited, and cos state would be a bunch of edges being excited. And now laws of physics. So hint topology, something where we don't put any data really. So, okay, a boundary known in topology. If you have an edge, a boundary would be the two vertices at the edges, right? And in case of the co-boundary, you have a state which gives you now the edges attached to this excited. And remember that everything is over Z2. So dynamics would be something like this. You have here a state. Co-boundary gives you now a cos state. But notice that the one connecting the two vertical ones disappeared. Why? Because 1 + 1 is 2, is excited twice, right? And then you're taking again a boundary, you're getting back into a state. So you have a process. And this big map, let's call it a harmonic map. It corresponds to harmonic map in electromagnetism, when you have a boundary, co-boundary, is it right? Okay. Here we have a process. We're starting with a one dot, and it evolves. We can think, so we have like two really processes, right? One on the surface and one underneath. And this is a little house scheduled for demolition. It looks like a computer. If you wait long enough, it should calculate 42, right? If you think about it as a computer. And so rules, homework, you have to figure it out by just erasing on the bottom, right? Here is a light trapped in a crystal. You can make a lot of experiments. Or for instance here, this behaves really like a light inside the crystal. It's bouncing there and back. Look what happens if we put a little distraction over there, right? Then it starts become really, I have to stop here, I have only 6 minutes. And now every graph corresponds to, so you can trace all these processes and make all possible evolutions, draw them, right? And so these are graphs, and these are the corresponding evolution. These are the states, and they all go, and eventually all they disappear. This is the one, you notice there are loops to which a little, like trees are attached. Here, longer trees, all they are binary here, and they go to loops. And these are the possible trees you can get. You're getting back into actually biology, a little garden. And this is a theorem I just want to flash to mathematicians that actually you can calculate those all evolutions with some mathematics using exactly like in quantum mechanics you would do. You have to produce a space of states. And yeah, don't worry about this. And So L means how many loops of what size do I have? Like for instance, L, the very first one, you have one loop of order 1, of order 3, and 2 loops of order 6, and so on and so on. 3 is those like the garden of the things growing, right? Okay, so summary, you have still a minute. And so if you compare it with the game of life, game of light is not exactly cellular automaton because you have those 2 processes on the level, on the 2 levels, right? And nothing has been chosen arbitrarily. It's just pure topology. Analogies with physics. We have this duality, which corresponds to wave-particle duality, maybe. Like this is like like electromagnetic duality. You have a Huygens principle of superposition and interference of those waves. Solution using like quantum mechanics state of space of states. For mathematicians, it produces a new invariance for graphs. By the way, this is for the game of life, the god of, right, the Green Man. And this is Lucifer, known also as Venus, the morning star. That will be corresponding to the light, right? And, for now, for metaphysics. So applications metaphysics, this is another interesting, this is tree of life, looks roughly like this. You can calculate the tree of all evolutions. That's the size 4, and you have then 9 loops of order 7, 7 plus 4, 11. Coincidence, maybe. And there is a suggestion that actually the tree of life has been based on the tetractys, right? So I just calculated for both of them the tree, and it turns out to be the same. So maybe that's true. Well, thank you very much.
Thank you very much.